Okay, all right. So let's start. These are the references. Please go through it if you want. I have taken references on these places because these gives me good, what do you call that, diagrams. And my lectures would have noticed full of diagrams, because with diagrams it becomes clear or easy to understand the topic. Okay, so today we'll try to cover these topics, and then later on we'll cover remaining ones, maybe tomorrow or uh, Wednesday and Thursday. Okay, this today. These are the two very good books or popular books. Okay, this book is available in downloadable version, so you can download it and read it. This book, of course, you'll have to buy. Both are very good books, so just get one of these. I will suggest the first one because it will not cost you anything. Okay. Initially, Bitcoin was not so popular, so not many companies, organization, and people were accepting Bitcoins. But today, situation is different. Okay, it's very popular and it's becoming more popular. Okay, out of many cryptocurrencies that have come in, only two survived, right? Of course, many survive or are still being used, but two of them, Ethereum and Bitcoin, are the most popular. Okay, now let's look at in brief what is blockchain, and then we'll look briefly at what is Bitcoin, and then we'll go into details. So before starting, can you please tell me what is a Bitcoin? Anyone? Yeah, what is a Bitcoin? You would have read about it, right? Some of you might have also used it.
Sir, it is kind of a digital asset.
Yes. Yeah. Yeah, more than that, what's so unique about it, right? I mean, even when do digital transactions, we have digital money, and many governments have started making their own uh, equivalent. Okay, when you do from bank to bank transaction, that's also in the money goes in form of digital currency, right? Digital form of the money. Or UPI, you don't look at the physical aspects of money. There's note or coin, right? So what is unique about Bitcoin? Why it has become popular? Yeah, think about it, na. You will get
Uh,
the answers. Yeah.
Sir, like it is like maintained using the blockchain data structures, etc. Other than matlab, bank transactions are maintained using centralized structures, but blockchain is kind of decentralized, so it maintains the anonymity of persons involved.
Yes. 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 Very good. Excellent. 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 So Bitcoin is basically an application of blockchain. Okay, and blockchain is a kind of data structure, centralized database, and distributed database, not centralized, non-centralized, distributed database. So Bitcoin is basically a digital currency created by the whole system, right? And that system is not owned by one person, and that's also being mined or being created. But of course, there's a limit. Maximum number of Bitcoin that can be created is limited. Okay, so anybody can create Bitcoin. So there is no government like government of USA or any Western country, England or India or whatever, can say that it's my currency. Otherwise, all the other currencies are basically created and has value related to that country's wealth. Okay, so now the question that comes to mind what it is, how it is created, how is it transacted, okay, how fraud can be avoided. Frauds, I mean, is a digital currency, right? Copying any digital asset is very simple. Okay, then how can you avoid that fraud? And it is peer to peer. When we say peer to peer, it means that from Alice to Bob, transaction can happen directly, and there is no bank in between or credit card company. The credit card company ultimately is linked to banks, right? There's no centralized authority like banks. Otherwise, today's digital assets, so, when you want to transfer money, you want to send me some money using UPI, then of course, it appears to you are sending it directly to me, but happens through bank where your account is, right? All right. So now let's look at it. We'll go into more details, but let's first look at blockchain. What is blockchain? So blockchain, abstract answer is that a blockchain provides coordination between many parties, many people, right, or parties, when there is no single trusted party. So if we can do transaction among two entities which are peer to peer without involving any third person or central person, then and that without any fraud, that's the aim of blockchain. Okay. If a trusted party exists, then there is no need for blockchain, right? Like banks. Now the question is a very important point here, statement. Do you think banks can be 100% trusted? I mean, the moment you put, 1 crore or 100,000, or, or so, uh, uh, put, for example, 100 lakhs or 1 crore kind of money in the bank, everyone in the bank will come to know about it, right? You will start getting calls from many parties about investments. Okay, what happened? Bank goes bankrupt. You have, say 10 lakhs of rupees in the bank and it goes bankrupt. How much money you will get? Any idea? We assume that banks can't go bankrupt, but it happened in US. It have also about to happen in India, like Yes Bank and many other banks, where there was a fraud by senior people and it was about to bankrupt, right? No, so banks or any central party cannot be trusted 100%. Okay, they know what you are doing. Okay, so, or is it possible for you, Alice, to send money to Bob without bank knowing about it? Can it be done? Yeah, I'm asking you guys. Until unless Alice goes directly to Bob and hands over currencies, right? Otherwise, all electronic transaction has got to go through something and banks will come to know. All right? Okay. So finally, system cannot be trusted. This is the point, next point, right? Okay. So the blockchain enables this kind of transaction which are peer to peer in secure way. Okay. So initially in 2009, Satoshi, who is Mr. Satoshi? Nobody knows in the world. he wrote a paper, and then based on okay, based on that paper, and he also implemented the first version of blockchain and Bitcoin, and since then this whole thing has started, right? And even till today nobody knows who is Satoshi. All right, okay, but the whole system is in operation. So we in 2009 blockchain Bitcoin came, and then similar idea in 2015 Ethereum has come. Okay, and then between 2017 and 2022, or now we can say till now 2023, a lot of apps are coming that uses blockchain. For example, can we use blockchain in banks? Can we use blockchains in, say, for example, to have medical records of people, right? And so on and so forth. So there have been lot of apps like, decentralized finance, DeFi, non-fungible tokens, decentralized autonomous operations, organizations. There are many, so which we are not going to study in this class, okay? But if you're interested, you can read about it, how new applications can be developed over blockchain. And also you'll have to find, first, in order to develop your blockchain, you'll have to understand what is the offering of the blockchain, what blockchain offers, such that these things can be, or applications can be done or implemented efficiently and in cost effective manner. Okay, so what is it good for? That's what is blockchain good for? Applications. Digital currency is the most important one, right? Like Bitcoin and Ethereum, these are two popular ones. And it has to be global, right? All the apps that is being developed, like Bitcoin or Ethereum, is accessible to anyone. Okay, like Bitcoin, anybody, you can participate, you can buy Bitcoins. And it really helped lot of people, because if suppose your currency is going depreciating very fast, and you have certain amount of rupees, like it happens in Argentina, it's happening in Pakistan, for example, their currency has depreciated significantly. Then the people want to migrate, right? The country that becomes weak, people want to go to richer place, right? Or richer countries, and then people can convert local currency somehow into Bitcoin and then take the Bitcoin. Okay, all right. So the people prefer to do trade in currencies that are non-depreciating. Okay, all right. So, and also it happened that Bitcoin has long, um, in many countries where dictatorship is there, it has helped people to retain some wealth. Okay? Because it's borderless money. Suppose you have to carry from your country, say 1 million units of that currency, and all these are coins, actual physical coins or note, then it's extremely hard to carry that to some other country. But through this mechanism you can do that. And there are also a lot of flip side of it, right? One can easily buy drugs or guns or whatever, because nobody knows who is a buyer and who is seller. Okay, all right. So a lot of decentralized application have come in. Now, when we say decentralized, it means that there is no central entity, there is no server entity that controls. It's all peer to peer. True peer to peer is governed by some protocol, some set of rules, right? Okay, like our networking that we have studied so far is all peer to peer. Okay, so all right, so transaction volume, these are becoming very popular. I mean, you can see the Bitcoin's transaction value volume was almost like 10 billion. Okay, Ethereum transaction values are 3.4 billion, and UPDC has transaction value of 2.7 billion. Okay, now, and a lot of people are also involved in the development, right? So you can see a number of people who are involved in the development of this technology for Bitcoin was this one, because Bit came much earlier, and there's a lot of interest in Ethereum. So you can see that a lot of developers have focused on development of Ethereum. So what does blockchain contain? It must have something which is for the consensus, right? Why do we need consensus? Because there is no centralized authority. If there is no centralized authority, somebody must say that this transaction is valid. How can, then there must be a set of people who will look at the transaction and validate that transaction. Okay, and there is concept of voting. Okay, so now transactions can be validated by some number of people. Okay, and that's called, and they reach at the consensus whether a transaction is valid or not. And then there may be large number of such transactions or orders, and they must be sequenced and put into a block. Okay, and then there is a whole thing has to be executed. It means that, I mean, if the Bitcoin has to go from Alice to Bob, and Bob in turn will send something. Okay, so that execution has to happen. Okay, all right, and then on top of that, these are three basic layers, and then there are applications. Okay, so now blockchain from the top, if you look at it, has many components. First is that, all these transactions that Alice, Bob, etc., and Bob and Mallory and all these people are doing must get into some database. Okay, and this database is distributed database which anybody can see, right? Which are time stamped and append only. So Alice has sent some Bitcoin to Bob. That may be one transaction. Okay, then Bob has sent something to Mallory, the second transaction, third transaction, and so on, so forth, right? Now, overall number of Bitcoins also being generated, that also is kind of, that information is available. So overall, this set of transaction, we can see this as a block. For example, each one is a block. Each block may be created every 10 minutes or 20 minutes. Okay, so these blocks get appended to each other, and this database, in terms of sequence of blocks, this may be first block, this may be, today there must be some block that's being created, just created in just 10 minutes back. All these blocks are visible and available to everyone. Okay, and these are auditable. You can see how many coins are generated, who's passing the coin to somebody else, and so on and so forth. Okay, and of course these are all secured with cryptography, and we use hash function, and hash function we use for integrity. And then when Alice is sending something to Bob, Alice has to sign that, and this signature is nothing but digital signature that we have also studied. Okay, and all such transactions that is being done must be agreed upon by set of people, and you can also participate in that the process, and these people are usually called miners. Okay, all right, any question? If there's no question, then it means that you are not able to understand, because it's not easy, right, topic. Okay, all right, so these lot of innovations are happening around this blockchain, and and cryptocurrencies. You can see a number of organizations are working on it. Okay, now let's go ahead. What should all these blockchain and crypto must have, right? We have already studied all this. Okay, these are the elements. Hash, that we have already studied, and something that we'll study here, which is nothing but a kind of hash plus a pointer. Hash plus pointer. Pointer is like pointer you have studied in your C class, right? I mean the C language class. Okay, pointer points to what is the address of some memory location. Okay, and hash is nothing but hash value. Then blockchain, which we'll study. Then something that we already studied is hash and digital signature and asymmetric encryption. Okay, all right. So these are the main things that it uses, and we are studying this crypto currency, blockchain, etc. at the end, because by the time you understand how basic cryptology works. Hash function, we will not spend time. You already know. I mean, it provides a signature of a kind of signature of uh, signature, or it reduces a large string of bits into a small string, right? Okay, so megabytes of data, when you hash it, it transform into hash value, which may be just 32 bytes, and so on, which is nothing but sequence of zeros and ones. Okay, and we have seen the properties of hash function. You change single bit in say original message, it change a large number of bits in hash value. Okay, and we have seen these this slide, of course, I have taken from the lecture that we have studied earlier. These are the property: deterministic, efficiency, security, the one-wayness, and second pre-image resistance, right? And then collision resistance. Collision resistance does not mean collisions are not possible, it's but finding collisions are difficult. Okay, all right, because you are mapping large space into a small space. Okay, so collisions may happen, but it is extremely difficult to find. Okay, all right, so these are the things that we have studied. One-wayness is, of course, given value of y. So y is output of y is the hash value. Given the value of y, it is very difficult to find. It's impossible, infeasible to find x, the original message, right, or string. Okay. Second pre-image resistance is that given input x, given x, we can calculate h of x. Okay. Now it is very difficult. Looking at this, it's difficult to find x dash such that h of x dash is equal to h of x. It's called second pre-image resistance, right? These two we have studied, and what we get is basically message digest. Okay, that we use in cryptocurrencies. All right. Now related to blockchain, Alice has a large file M. She posts hash of that with h of m, which is 32 bytes. So h of m is 32 bytes. Okay, Bob reads h, and later he learns about m dash such that h of m dash is equal to h, same as what this one. If the function is CRF, which is collision resistant, then Bob is convinced that m dash is equal to m. So h is equal to hash value small h is equal to hash function of message m is a binding commitment on m. It means that it's not possible. First thing is that given m, given h, you cannot find out m, and secondly, this h is actually hash output of h of m. Okay, so that this we know, right? Now next thing that we want to learn is what is hash pointer. Hash anyway we know by now, is it we use it for checking integrity of a message. Pointer is a data structures, you would have studied, right? Okay, this is nothing but address or memory location. We'll say that there is a block of memory and this is a pointer. Pointer is nothing but starting address of this, and you know how to manipulate pointers, yeah, if you have done a course on programming. Okay, so hash pointer is a tuple, which it means that it has two elements. First is traditional pointer. So if this is a block, the hash pointer will have two elements. First is a pointer to this one, and then second element is complete, do the complete hash of this block, let's call m, and then put that value of h of m here. Okay, so hash pointer is used to validate the information being pointed to, that, and that has not been modified. So we'll come to this one. Any question up to this point? Are you able to understand what is being told? Okay, so hash point, note that I will ask good number of questions from this topic, so be attentive. Okay, and it's also interesting also, right? It's not only for exam, but it's interesting. So hash, what is a hash pointer then? Hash pointer is a pointer to the data and hash value of the data. So this is the data element. Okay, you calculate the hash of this data, and there is always a pointer to this, right? So we'll have a pointer. Okay, so we'll say pointer here and hash of data. This become hash pointer. So this pointer points to this one starting address, and hash of data is you take this data and do the hash of that, and hash function is known to us, and then you keep these two values, the pointer value and hash value, and call this tuple as hash pointer. Okay, so what happens, for every data or every block you create hash pointer, and if someone changes, Mallory changes the data here, what will happen? And when the hash of this is taken, then it will not match with the hash that was calculated earlier. Okay, so it means that if hash pointer is somehow kept securely, then any manipulation data by anybody would can be found out. Okay, all right, so let's look at this. The same thing is, I am repeating here, this hash pointer is nothing but a pointer which is nothing but address of that element that is pointing to, suppose pointing to this block of data, then this address is starting address of this, and for all the elements here which are zeros and ones, you do hash of this data and keep it here in the pointers. This is second element of that tuple. Okay, now let's look at how we can create blockchain, which is nothing but a linked list. Okay, now this is the first block that was created by Satoshi Son, who invented, huh? Okay, it had number of transactions. Okay, and then top of that is a hash pointer. Now since this is the first block that is created, obviously it will be null. Okay, and then you okay, so let's start from start. Okay, let's I will just clean it up and then see how it was created. So this is the first block. Okay, and then you will have a hash pointer to this, and top is of course hash pointer to previous block, which is null. All the transaction which Bob, Alice, Mallory, etc. have done will come here. Okay, now this will have two elements. First is hash value, let me say hash value here, and second is pointer. So pointer is this address, because this block is not somewhere in the memory. Okay, is a pointer to this one, and this hash is nothing but look at all these things and calculate hash of all this, hash of this data. First block is here. Okay, now this block is added after it has some length, some number of elements. It cannot be infinite length, some length that's defined, or some time limit that's defined, and after that second block is to be created. Okay, so how do we add then second block to this one? This is the first block, so we create the second block. Okay, and now here we have hash pointer, which is nothing but that comes here. Okay, all right, and then obviously the pointer will point now to this one, because we just copy it here and then modify this head pointer by two elements. First is address or pointer of the second block, and then second element is complete hash of this. Okay, so in this way we create this first block, and then when this second block is to be created, we copy this head pointer which was somewhere here earlier, which was pointing to this one. We copy it here, and then create a new head block, the head pointer, and one element will point to this, other will have hash value of this one, and so on and so forth. We continuously add in this way, and this blockchain even is alive, right? From the first Genesis block which Satoshi has created till now is available, and every 10 minutes or so one block is being created. Now the question that I am asking is, now how does all this hash pointer etc. help? We have seen how blocks are getting added. Anyone?
Like if any hash pointer is changed, or if it
Yes.
is like someone has hacked into and changed the data, we
Yes.
can tell
Yes.
that particular blockchain is
Yes.
invalid and we don't have to
Very good.
count it.
Yeah. So let's assume that here Mallory has changed this. Okay. If this is changed, then hash of all this will not match with the hash value here. And okay. All right. Now this is also changed. It means that this has to be changed in order to match. So Mallory is able to change the hash value here also. Then the hash value here will not match with all this. Okay, hash, complete hash of this block, right? And so on and so forth, right? So ultimately, in order to make change here, Mallory has to change everywhere here, the hash pointer of all blocks. Okay, and then if let's assume Mallory is able to do that, but yet if this is protected, then we'll find out that some blocks are changed, and it can be easy to find out what has changed. Okay, all right. So repeat, if this is changed, then Mallory has to change this one, and then Mallory has to change this one in order to avoid detection, and she has to change this one, but she cannot change this. So ultimately, if somebody tries to do this, will be detected. Okay, all right. So this is a simple funda. All right. So the adversary will have to change all the hash pointer back to the head. And if we keep the head of the list safe, this safe, that's so an adversary cannot modify, then we can always detect tampering. Okay, please go through it. So that was the first data structure that we required. Second thing that we need is digital signature. Okay, so we have already studied this, right? So how do we have digital signature? Now this is where asymmetric key encryption comes into picture, right? Okay, so what is if Alice and Mallory, Alice and Bob are exchanging messages, Alice will generate public key and private key. Okay, so you can say SKA and PKA, and similarly Bob will generate public key of Bob and secret key of Bob. Okay, when Alice wants to send something and Bob needs proof that it has come from you, then she will use her private key to sign the message, right? And that becomes signature. Okay, all right. So this is what we have studied. So it has three phases. First is generate. Alice, for example, will generate secret key and public key. Okay. Then original message, she uses secret key to sign, and this becomes signature. Okay, signature here. And then Bob receives it and wants to verify it. Then he has to use public key of Alice, message M, and the signature. Okay, and then can verify whether yes or no. We have studied this in detail, right? Okay, all right. So the same thing that we have studied earlier. Okay, all right. Now how to use then digital signature? Exactly same thing here also. Every user of blockchain or cryptocurrency has to sign any transaction that he or she is doing. Okay, and everybody else, based on the public key and the signature on message, can verify that. All right. Okay, now what kind of digital signature mechanism we are using? Blockchains can use RSA, but it is old technology. It is not used. Something that is used is called Schnorr or ECDSA. Of course, we have not studied this, but both Bitcoin and Ethereum use Schnorr and ECDSA. Okay, and then of course their third scheme is called BLS signature, which is 48 bytes long, and it's used in Ethereum next version. There's something called Chia and Definity. Okay, but Bitcoin, note that Bitcoin uses Schnorr and ECDSA. Okay, all right. Now signatures are used at many places. First thing is used for transaction authorization. We can use it for governance nodes and also use in protocol nodes, protocol votes. Okay, we'll look at some of these little later. But whatever transaction Alice and Bob are doing, they have to sign. For example, Alice sending Bitcoin to Bob, then she has to sign that with her own signature, which anybody can verify. Okay, any question? The question now is that if everyone can see the transaction, where is the confidentiality? Okay, of course there is some amount of confidentiality, 100% we can say, because all the transaction in Bitcoin etc. happen only with the keys PK and SK. And who is generating PK and SK? Alice herself is generating PK and SK. Okay. Now this is a very large number randomly generated. So people can come to know that somebody who has PK is doing this transaction, but who has PK nobody knows. Okay, all right. Any question? Sounds strange? How about two people generating same? Everyone is randomly generating PK, right? You generate, I will also generate. Okay, both can have same value of PK. Is it possible? Because absolutely distributed, there is no bank who will say this is your PK and SK. You are generating by yourself using some algorithm PK and SK. Then how will you ensure that Mallory does not have same PK? Otherwise, she can claim everything, right? So it's like the probability of this PK size is so big. Even if the 256 bits, then probably randomly generating that, I'm assuming 256, it will be 512 or 10 or 1K size, 1K bit size. What is the probability of having, say, randomly picking up 1 out of 2 raised power, say 512? You're randomly picking it, right? And this number is, this probability of 2 having very, very small is same probability as you go to Goa beach. You pick up a grain of sand, you color it with red color, okay, and drop it. And you ask your friend to go and pick up one grain randomly. If it happens to be same grain, then that probability is actually smaller than probability of the one here. Okay, all right. So it means that now, of course, two parties can independently generate, or any number of parties can independently generate their own PKs and SKs. And these PKs and SKs can also be for limited time, for few transactions or maybe one transaction. They keep on generating this. All right. And then it means that if you have some Bitcoin and you generate new address for yourself, then you have to transfer it to yourself, to the earlier one to yourself, your sender and also receiver. Of course, we'll look at some of these aspects later. Of course, not fully. So Bitcoin, we already studied in brief, is crypto, of course, based on cryptology. Okay. Now anybody uses the word crypto is cryptocurrencies largely. Earlier, crypto means the cryptology. It means the encryption, decryption, and so on, right? But the general public knows crypto only with cryptocurrencies. Okay. So cryptocurrency is completely digital, formless currency tied together using computer science, cryptography, and economics. And Bitcoin, of course, is the most popular cryptocurrencies. And blockchain, we have seen, is a data structure behind cryptocurrencies, method of storing data among multiple parties that ensure data integrity without requiring trust. Now that's important. Without requiring trust, what do you mean by that? So all the transactions are validated by a set of people, and they do voting. Okay, some of these people who vote can also be malicious, but yet whole system should work. Okay, so majority wins. Okay, all right. Just few minutes on what is cryptocurrency. There is no central authority, and its state is maintained through distributed consensus. When you say no central authority, it means that it is peer-to-peer. All transactions happen absolutely between two entities. Okay, so if you want to buy a gun, you can just transfer Bitcoin, a part of Bitcoin, to somebody who sells gun and will supply you gun. Nobody will come to know. Otherwise, government can track, the money that's being received by gun seller and can find it out. And there's, of course, there's a big problem of cryptocurrency because people are doing all in dark web, etc. You can get anything you want. Okay. So system okay, the system gives an overview of cryptocurrency units and their ownership. So there is, of course, distributed system. Okay, when we say there is no central authority, does not mean there is no mechanism to keep all the track of transaction. Like blockchain is a one such mechanism. So system, and then it has to define how cryptocurrency is being created. Who can create cryptocurrencies? Because ultimately, if anybody can create cryptocurrency and any number, then the whole thing will fail. Okay, and then if you own the cryptocurrency, you should be able to prove that you have it, and everybody should also be able to prove, yes, you have earned this many or you have got this many crypto coins. Okay, so ownership of cryptocurrency can be proved exclusively and cryptographically. Okay, the system allows for transactions, so it should allow transfer of crypto, the bitcoins, and can also occur from the entity that can prove ownership of source. So Alice should have crypto money to transfer it to somebody else. If Alice does not have, then she cannot transfer, right? So that mechanism, now it looks very obvious to us, but how to implement this thing in system, that's very important. Okay. Okay. So if two different instructions for changing ownership of the same cryptographic units are simultaneously entered, then system should perform at most one of them, which is very obvious, right? So this transition is happening from our currency to Bitcoin. You can buy Bitcoin now. Okay. Of course, it's linked to the local currency, but this linking is, you may say, is official or non-official. Nobody knows. Government of India does not publish the value of Bitcoin in terms of, so all this happened through US dollar and then other currencies, that dollar to whatever currency conversion happens, and then Bitcoin has some relationship with local currency. Okay, so currency, I mean, this of course is some history. Initially we had, before physical cash, we had all this barter system. We'll not go into it because we are interested in technology, not actually about learning how currency works. Then physical cash, it moved to credit card and debit cards. Okay, electronic credit and debit transactions. Now you have UPI, etc., etc. But with all this traditional way of paying digitally, okay, Alice sends it to Bob, say credit card details, etc., etc. Bob may be merchant. Okay, and then everything happens through bank. Okay, okay, or you may want to transfer money from your account, or Alice wants to transfer it to Bob's account, then again it has to happen through bank. Okay, so basically it requires trust on financial institution, and the whole idea is that you cannot trust anybody. And of course, why should you pay fee? I mean, look, even you're going abroad and you want to carry some amount, okay, this transaction fee or the commission you can pay can be as high as 4 to 5%. For what? Okay, the banks loot you. Okay, and everybody knows in the whole banking system who is doing the transaction. Okay, so everything we have seen earlier, central entity was involved, and then 2008, Satoshi Nakamoto, Japanese of course, but nobody knows who is he, wrote this classical paper, peer-to-peer electronic cash system, Bitcoin. Please read this. Okay, and then came blockchain in the idea, and then Bitcoin. Okay, and now Bitcoin can do transaction between two, Alice and Bob, without it going through bank. Okay, so Bitcoin is cryptocurrency whose rules are defined by cryptography. There's no trusted party in between. So Alice will not send it to bank, and then bank will transfer it to Bob. So basic whole idea is that avoid trust on institutions. Okay, it could be, the reasons could be ideological, financial, pseudo-anonymity, and so on and so forth, right? You may not want bank to know or government to know what you are doing, right? All right. So Bitcoin, of course, we are coming towards the end of the lecture, is end-to-end peer-to-peer cryptocurrency, distributed decentralized crypto system. It's released by Satoshi Nakamoto in 2008. It defined what the whole system is of blockchain and Bitcoin. It runs on internet. If you don't have internet, you can't do anything. Ingenious ledgers used to keep track of all transactions, that's called blockchain. Now the question is that how do you trust this ledger, which is blockchain? So it must be, this problem is solved using crypto. Okay, using hash and digital signatures and so on and so forth, right? Okay, all right. There's no trusted party in between. Suppose Alice likes Bob. This is a fun part, right? So input is A is 1 if Alice loves Bob, 0 otherwise. If Bob loves Alice, then it's 1 and 0 otherwise, right? And then in order to reach the consensus, Y is A and B. If both are 1, then they should agree on living together and marriage. Okay, and this used to be the model. I mean, your parents would have got married using this model, where is a trusted third party, your father's uncle, aunt, or some relative or somebody would have told his boy, girl is good, and so on and so forth, right? Now how can this is the real world even today, but this is the world now. Okay, Alice wants to communicate directly with Bob and agree on getting married. And so we are transiting from this model to the model here. This is a government controlled or bank control or central entity controlled model to totally distributed model. Now the question is that now how trust can come between the two, and that problem is being solved using blockchain and crypto. Okay, all right. Now good thing is that if there is no trusted server, anybody can join the system. Users are not registered by any authority and user can contact each other. Okay, so it's a peer-to-peer network. Okay, and it's based on some kind of voting. They have to agree. If Alice is sending transaction to Bob, then everyone will look at it and then say that whether this transaction is correct or not. Alice cannot send bitcoins to Bob if she does not own the bitcoins. Then all these people will check how Alice has actually earned these bitcoins based on the past transactions, and then can say the transaction is valid or not. So it's based on the voting. Okay, and votes are secret, votes are correctly counted, and consensus is reached, right? Okay, so if there is no trusted server, okay, then lot of things can be done peer to peer. Okay, but note that the amount of money that can ever be printed, which is around 20 million BTC, is fixed. And of course miners, by cracking some puzzle, are earning bitcoins, but as time passes earning bitcoin becomes much more difficult. So this is the limit. So overall value of this cryptocurrency will go up, okay, if this is true, right? Of course government regulations can bring it down, of course. All right, so please go through this. All right, so what we studied today is some basic concepts of blockchain and Bitcoin, which are becoming popular. Bitcoin is an application of blockchain, and the Bitcoin does not rely on any central authority because it's a peer-to-peer, and of course it's becoming popular, very popular. All right, so that's all for today. Any question?
Excuse me, sir.
Yeah.
I
Just a
wanted
minute.
to talk regarding the.
Just a minute. Just a minute. Let me stop recording.
Sure, sir.